Good morning. I'm Dr. Parameswari, Assistant Professor, Department of Mathematics, Sathyabama Institute of Science and Technology. Today we are going to see change of order of integration as part 3. In the previous parts, we have seen the region as the single region. Now we are going to see the region is going to divide into two sub-regions because of the intersecting point of the curves x is equal to y and the curve x plus y is equal to 2. Both the curves are meeting at the point x is equal to 1 and y is equal to 1. So, the region is dividing into 2. We are going to proceed in the problem. See, this is a question. Change the order of integration and evaluate. This is also very important question because here in this question, the region is going to divide into two parts. With the division of two parts only, we can evaluate this once if you are changing the order. If you are not changing the order, the function is easy. You can proceed easily to evaluate. But the given question is change the order of integration and evaluate. Okay. So, the integration is outer limit is 0 to 1. Inner limit is y 2 minus y, function of y. So, function of y means the inner integration is with respect to x. So, given order is correct. No need to worry about the order. Given question is in the correct order. Now, we have to write the boundaries and then only we are going to change the order. Okay. The region is bounded by x is equal to y and x plus y is equal to 2. Actually, x is equal to 2 minus y and bringing that variable to the left hand side. So, we are getting x plus y is equal to 2 and the outer limit is for y, it is y is equal to 0, y is equal to 1. Okay. So, we have written the region boundaries and drawn the region also here. See, we have got the region here. X is equal to y. X is equal to y is a line passing through the origin. And we are having x plus y is equal to 2. When x is equal to 0, y is 2. So, that is a point here. When y is equal to 0, x is equal to 2. So, that is a point here. So, joining those 2 points, we are getting this line. And y is equal to 0 is nothing but x-axis. Y is equal to 0 is nothing but x-axis and y is equal to 1 is a line parallel to x-axis. So, this is a point we are having. So, in this intersection of lines x is equal to y and x plus y is equal to 2, we are having the intersecting point as 1 comma 1. We are having the intersecting point as 1 comma 1. Okay. So, in that point y is equal to y line will meet, right. So, this is the region and now what we are going to do? We are going to change the order. Order must be dy dx. We are going to change the order as dy dx. If it is dy dx, what we have to do? We have to draw the strip parallel to y axis. Vertical strip we have to draw. Vertical strip we have to draw. So, this is the vertical strip and what we can do? We can draw anywhere in the region. We can draw anywhere in the region and some of you may draw on the left side of the region or some of you may draw on the right side of the region or in the middle. In this problem alone, if you are drawing on the left side or on the right side or in the middle, you will get different limits for y, not the same unique limits for y. In those two problems, we got the unique limits, but here some of you may draw on the left side and some of you may draw on the right side and some on the middle also. You will be getting 3 different limits, which is not correct. Why? Because the region is divided at this intersecting point. The intersecting point is 1 comma 1. So, because of that intersecting point, we are going to divide the region into 2. Okay, we are going to divide the region into 2. So, for both region 1 and region 2, we have to evaluate. Adding together gives you the integral value of this. Okay, so that's what we have drawn the strip on the left side also, that is before this x is equal to 1 and after x is equal to 1, we have drawn one more strip in that region. The whole region is intersecting at this point. So, because of that, we are having 2 regions. In those 2 regions, we have drawn. See, in this vertical strip, the lower end touches the boundary y is equal to 0. So, for region 1, the limit of y is 0 and y is equal to x because it is touching the line x is equal to y. So, we are having y is equal to x, okay. And in this region 2, on the right side of the line x is equal to 1, here also the lower boundary is same, y is equal to 0. But the upper boundary differs because the upper boundary is touching the line x plus y is equal to 2. We have to write for y. So, y is equal to 2 minus x, okay. If you are moving the strip towards left direction, x will meet the point O. So, x is equal to 0. Towards right direction, it will meet the line x is equal to 1. So, for the first region, the limit of x is 0 to 1. Okay. And similarly, for the second region, moving the strip towards left direction, where it will meet the line x is equal to 1. It will meet the line x is equal to 1. And moving towards right direction, it will meet the point x is equal to 2. Okay. So, for the second region, the limit of x is 1 to 2. Okay. So, that is what we are going to see in the next slide. See, in the previous slide, we have seen the region. The region is on the whole, it is meeting the point O, A and B. And in between, we add the line x is equal to 1. So, that point is mentioned as C here. So, the region is divided into 2. So, OAC plus CAB. And I have explained the limits of both the regions. So that is what we have written here. Integral 0 to 1, integral 0 to x, xy dy dx, plus for the second region, that y is meeting, the upper boundary of the y is meeting the point line x plus y is equal to 2. So, we are having the limit is 0 to 2 minus x and the outer limit is 1 to 2. Now, we have to integrate easily. We can integrate easily because we are going to treat the other variable as constant if we are integrating with respect to y. So, x is a constant here. So, integrating, outer integral is having remains the same 0 to 1. So, x y squared by 2, integral of y squared by 2, and that is between the limit 0 to x dx. And here also x y squared by 2, same function, integral 0 to 2 minus x. Now, we are going to substitute the limit for y. So, it is x squared will get here. So, x squared into x, x cube, and taking that 1 by 2 constant outside. Here also we can take 1 by 2 outside, x into 2 minus x the whole squared. Now, expanding, integrating this x cube, we will be getting x power 4 by 4, and that is between the limit 0 to 1. And to proceed the integration easily, expand this, multiply this x inside the bracket, and then we can use x power n formula alone. That is enough, integral x power n. That only we will be using in this. So, integrating, we are getting 4 into x squared by 2 plus x power 4 by 4 minus 4x cube by 3, and that is between the limit 1 to 2. Now, substituting the limits and simplifying, we are getting the answer is 1 by 3. So, the integral value of the given integration is 1 by 3. I hope you understood the concepts which we have discussed in all the 3 parts. Thank you.